Okay, yeah, so what we are going to do is to find the solutions of this second order differential equation with constant coefficients. The solution will be C1y1 plus C2y2, but before that I have to tell you what is linear independency concept. Okay, so because these are the solutions, so we need the y1 and y2 to be linear independent. What does that mean? Means that they are totally different. Assume that you have, let's assume that you have the first solution to be just, for example, x squared. And my second solution is going to be 3x squared, my second solution. Now, this cannot be because they are actually linear dependent. What is linear dependent? Well, the y2 is just 3 times my first solution. So the second solution is 3 times my first solution, x squared. So that means that I can build the second solution time with the first solution times a constant. So that means that my first solution is just here, y1, and my second solution is here, just 3 times. My second solution is just 3 times my first solution. So in the end, it is not the second solution y2 here is not a different solution from my first solution, because they go in the same direction if you take the concept of vectors. So they are not in different direction. They happen to go in the same direction. So it is just the same solution. So when you happen to have this, then what happens here is that in the end you only have one single solution. So my second solution shall be totally different from the first solution. So that is the concept. So we have to ensure that the second solution is totally different from the first solution, but they are solutions of the differential equation. Alright? If we happen to have this, in the end we only have one solution. So we only have one solution because my second solution is just 3 times my first solution. So we still need to find the second solution. Okay, so this is linear dependent. Now let me give you one example of linear independent. Let's assume that you have y1 equal to x squared, and my second solution is just the natural log of x. Okay, so it is totally different because I don't see how can I make the second solution time equal to times a constant meaning a number times my first solution. There is no constant like 5, pi, minus 3, whatever, that I multiply my first solution and I get the second solution. Okay, so this is clearly, there is no such constant that can give me this equation. There is no way I can multiply a number times this x squared and I magically get the natural log of x, so there is no possible. So these are linear independent. So what happens here, engineers, is that the main takeaway here is we want the solutions to be linear independent. Okay, so that's the main takeaway, the most important thing about this video. Now there is a formula to know what is there is a formula to test if it is linear independent or it is linear independent. Okay, and the formula is something called Wronskiano. Wronski. So it is just the Wronski formula. Okay, the Wronskiano is something like this. The Wronskiano of the first solution and the second solution is equal to a determinant of the first solution and the second solution in the first row, and in the second row the first solution but derivative and the second solution derivative. Now, if this is equal to 0, then it is linear dependent, LD. Now, if it is different than 0, then it is linear independent. Okay, so what we want is just the linear independent. And it is very similar to the vectors. Now, if they happen to be in the same direction, one multiplier of the other, then the determinant is equal to 0. So we don't want that to happen. Okay, from where this formula comes from, I'm going to talk about in a video later, from where this comes from, but you will see this later. Okay, now let's do the test of these two that are linear dependent. Okay, so let's do the test. So the Wronskiano, sorry, I'm going to use black. The Wronskiano of x squared and 3x squared. So that is equal to x squared, 3x squared, and here the derivative of each one of them, 2x, and then here 6x. So what is the result of this? So this is going to be this times this, 6x to the power of 3, and the other one is this times this, but it is negative, so 2 times 3, 6x to the power of 3. Now, this addition or subtraction leads to 0. So that means that they are linear dependent. Alright, so that means that this is the second solution is the same as the first solution. Right, so we need to find the second solution. Okay, now that is the test with the x squared with this set of solutions. Now let's do the test with this set of solutions. So I'm going to erase this part. Very similar process. Okay, so the Wronskian here is going to be x squared, comma, the natural lorem of x. So it's going to be the determinant of x squared and the natural lorem of x according to the formula, the first solution and the second solution. And here is going to be 2x, and here the derivative of this is going to be 1 over x. Okay, so this times this is going to be x squared divided by x is just x to the power of 1, and then minus 2x, the natural lorem of x. Okay, now there is no way this cancels, alright? And we can factorize the x is going to be x times 1 minus 2 the natural lorem of x. Okay, so there is no way this could be 0 except that maybe this is different than 0. This is different than 0 as long as x is different than 0. But because it's just one single point where it could be 0, so but in the majority of the numbers it's going to be different than 0. Because of that, then this set of solutions, they are linear independent, Li. Okay. So so what happens here is here with this formula you can test if your solutions are linear independent or linear dependent. If they happen to be linear dependent, that means that you have repeated your roots, your solutions, and this solution is the same as the first solution. Now, if it is linear independent, that means that your second solution is totally different from the first solution. Why we need this? Because we have to make sure that we have all solutions and we don't have repeated solutions. Alright? Okay, next video we are going to make the solution of this differential equation. Alright? See you in the next video.